All right, let's talk about NumPy. That's short for numerical Python, by the way. And look, if you're doing anything with data in Python, especially big data sets, this library is, well, it's everything. It's basically the engine that makes the whole data science world go round.
So let me ask you something. Have you ever been there, working with a huge list of numbers in Python? You're trying to do some math and it just crawls. It feels so sluggish, right? Well, you're not imagining things. There's a really good reason why that happens. And here's the solution: NumPy. It gives you this special kind of array that can be up to 50 times faster than a regular Python list when you're doing math. Yeah, you heard that right. 50. That is not a typo. It is an absolute total game changer.
Okay, so how is that even possible? Let's break it down. Think of it like this. A regular Python list is super flexible. You can throw anything in there, numbers, text, whatever. It's great, but that flexibility makes it slow for heavy-duty math. Now, a NumPy array, it has one rule. Everything inside has to be the same data type. It's stricter, for sure, but because of that rule, you get this blazingly fast, optimized highway for all your numerical calculations.
So, what's the magic trick here? Well, there's a fancy term for it: locality of reference. But here's what it really means. Imagine a Python list is like a bunch of books scattered all over a library. Your computer has to run around to find each one. A NumPy array, on the other hand, is like having all those books lined up perfectly on one single shelf. Your computer can just grab them all in one go. It's way, way more efficient. A simple idea, but it makes a huge difference.
All right, enough theory. That's cool and all, but how do we actually do this stuff? Let's get into the code and build our very first NumPy array. And trust me, you're going to be surprised at just how easy it is.
Okay, check this out. It's really just 2 steps. First, you got to import the library. Everyone does import NumPy as NP. That NP is just a standard shortcut. You'll see it everywhere. Then you literally just take a normal Python list and you wrap it in np.array. And boom, that's it. You've just created a NumPy array, or an ND array, which is the official name, and you're ready to tap into all that power.
Okay, before we go further, we got to talk about something called dimensions. It's a really key idea in NumPy. So what's the simplest array you can possibly have? Just a single number, that's it. We call this a 0D array, or a scalar. Think of it as the most basic Lego brick of the whole system. Now, what happens when you take a bunch of those single numbers and put them in a list, just like we did before? Well, you get a one-dimensional array. You can picture it as just a simple line of numbers. This is probably the kind of array you're going to use most often. Okay, let's level up. What if you have a list that contains other lists? Well, that's how you make a two-dimensional array. And this is where it gets really cool, because this is basically a table or a matrix. You can use this to represent a spreadsheet or even an image where each number is the color of a single pixel. Super powerful stuff.
And hey, if you're ever not sure what kind of array you're dealing with, is it 1D, 2D, or even more, NumPy has your back. You can just type .ndim right after your array's name, and it'll spit out a number telling you exactly how many dimensions it has. It's a really handy little trick.
All right, so we know how to make arrays. Awesome, but now we need to know how to get specific pieces of data out of them. So next up, accessing and slicing.
And here's the best part. If you already know how to grab an item from a regular Python list, you already know how to do it in NumPy. Seriously, it's the exact same square bracket thing. And yeah, the first item is always at index 0. Nothing new to learn there. But what if you don't want just one item? What if you want a whole chunk of them? Well, that's called slicing. It's a super powerful way to grab a piece of an array. To see how it works, let's start with this simple array we've got here with the numbers 1 to 7.
Okay, now pay close attention to the code array 1 to 5. This is the secret sauce of slicing. It basically says start at index 1, and you do include that one, and go up to, but don't include, index 5. So what are we actually grabbing? We're getting the elements at index 1, 2, 3, and 4. And there's our result, a brand new array with just those numbers, 2, 3, 4, and 5. It might seem a little weird at first, that whole include the start, exclude the end thing, but once you do it a few times, it just clicks. It becomes second nature.
Okay, I need you to listen up for this next part because this is super, super important. This is one of those things that trips up almost everyone when they're starting out, and it can cause some really sneaky bugs that are a pain to track down. We have to talk about the difference between a copy and a view.
It all comes down to one thing: who owns the data?
A copy is exactly what it sounds like. It makes a completely separate, brand new array. It's got its own data. You can mess with it all you want, and the original array won't even notice. But a view is different. It's more like a window looking at the original data. It doesn't own anything. So if you reach through that window and change something, you're actually changing the original.
Let's see a real example. So here we make our array, and then we use the .copy method to make a new one. Now watch this. We change the first number in our copy to 42. Then, when we look at the original array again, see, it's totally untouched, exactly what we'd expect.
Okay, now let's try that again, but this time we'll use .view. We create the view, we change its first element to 31, and whoa, look at that! The original array changed too. See the difference? Understanding this is absolutely critical, otherwise you might change your data without even realizing it.
Okay, so now that you've got the basics down, creating arrays, slicing, and the whole copy versus view thing, let's get to the really fun stuff. Let's look at some of the powerful built-in functions that make NumPy so awesome for data analysis.
So imagine you've got this giant array with thousands of numbers, and you need to find the position of every single 4. You could write a loop, or you could just use np.where. We're basically just asking NumPy, hey, where in this array is the value equal to 4? And bam, it gives us back a new array with the indexes of every match. In this case, that's at index 3 and index 5. So fast.
Or how about sorting? Another one of those things that can be a hassle sometimes. With NumPy, it's a piece of cake. You just call np.sort on your array. That's it. NumPy takes care of the rest. And it doesn't just work for numbers. As you can see right here, it sorts text alphabetically too. One simple command, and everything is in perfect order.
All right, and this last one, this is one of my favorite tricks in all of NumPy. It's called Boolean filtering. It sounds complicated, but it's not. You can create a sort of mask of true and false values based on some condition, right? And then you can use that mask to pluck out only the values from your original array that lined up with true. It is such a slick and powerful way to zero in on exactly the data you care about.
So there you have it. We've gone from why NumPy is so fast all the way to creating, slicing, and using its powerful functions. Honestly, these are the core building blocks for just about everything you'll do in data science or machine learning with Python. You now have the tools, so the only real question left is, what are you going to build?